Hello. Rational functions is our topic for today. So we're going to talk about a function r of x that is made up of a function f of x over g of x. So it's a fraction made out of polynomials. So f and g are polynomials. The g of x function cannot be equal to 0. Okay? So something we want to know about a rational function is its domain. Okay, which we've talked about several times before. So the domain of a rational function is going to be the set of all real numbers except zeros of its bottom, okay, of its denominator. Okay, every rational is continuous on its domain. Okay, so if I ask you about continuous, is it continuous? We would say yes, on its domain. Okay, so that's something else we know. Okay, so let's take a look at one of these. Let's say that f of x equals 1 over x minus 2. Okay, so if you think about that as far as its domain goes, what do we know? Well, on the bottom, x cannot be 2, because that would make us a 0 on the bottom. So for our domain, we'd say negative infinity to 2, and then to infinity. Okay, so that takes care of that. So then the other part would be, if I take a quick look at the graph, we know by transformation that this graph is going to move 2 to the right. Okay, and if you think of the parent function, it's going to go like this, and then again like this. Okay, and we have a quick sketch, right? So we've worked a little bit with our limit statements. So consider this, as x goes to 2, and I'm going to put a little negative sign up here for our function f of x, what happens? Well, you have to understand this part here is from the left. So as I'm approaching, as our f of x is approaching 2, this is x equals 2, from the left, so left hand, you're approaching this asymptote. What is your graph doing? It's going down, 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 so we would say it approaches negative infinity. All right? Then we'll do it again. The limit as x approaches 2 from the right, okay, so right hand, approaching this asymptote, approaching. What's your graph doing? Up, 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 towards positive infinity, okay? So maybe we can make a little rule or generalization for how that's going to work, okay? So we're going to have a vertical asymptote at x equals a, whatever a is. In this case, x equals 2. If the limit as x approaches a from the left is going to plus or minus infinity, so it's either going up or going down. So it approaches, it goes up or down. And, okay, or depending, the limit as x approaches a from the right, with that little plus sign there, goes to plus or minus infinity, okay? So our limit statements were going to plus and minus infinity, so absolutely we have a VA over there, okay? The other part is an HA, okay? Y equals B is going to be an HA if the limit as x approaches negative infinity for your function, whatever it is, goes to B, and or the limit as x approaches positive infinity, so we're going out to the ends on these, okay, for your function, also goes to B. If that happens, then we have a horizontal asymptote at B, okay? All right, so let's take a look at a full example. erase this real quick.